What happens when the exponent is a fraction and the numerator is 1? For example, let's calculate 4 to the 1/2 power. Using the properties of exponentiation, we claim that 4 to the 1/2 plus 1/2 is equal to 4 to the 1/2 times 4 to the 1/2. Since half plus half is 1, 4 to the 1/2 plus 1/2 is equal to 4 to the first, which is 4. Thus, 4 to the half times 4 to the half is equal to 4. Which value, when multiplied by itself, equals 4? 2 times 2 equals 4, so the answer is 2. In other words, 2 times 2, which is 2 to the second power, equals 4, so 4 to the half is equal to 2. Note that negative 2 times negative 2 is also 4, so 4 to the half is also negative 2. When we raise a positive number to the half power, we always have two solutions. Next, let's try calculating 9 to the half. As before, we claim that 9 to the half plus half is equal to 9 to the half times 9 to the half. And 9 to the half plus half is equal to 9 to the first, which is 9. Then 9 to the half times 9 to the half equals 9. Since 3 times 3 equals 9, 9 to the half equals 3. As before, negative 3 is also a solution. In general, x to the half times x to the half equals x. Suppose that y times y, or y squared, is equal to x. Then x to the half equals y. Similarly, if the exponent is 1/3, then x to the third times x to the third times x to the third equals x. Thus, if y times y times y, or y cubed, is equal to x, then x to the 1/3 equals y. For example, if x is 8, then 8 to the third times 8 to the third times 8 to the third equals 8. To calculate 8 to the third, we need to find a value that we can multiply 3 times to get 8. 2 times 2 times 2 equals 8, so 8 to the third equals 2. Note that negative 2 is not a solution, because negative 2 times negative 2 times negative 2 equals negative 8. When we raise a number to the third power, we only have one solution. Finally, if the exponent is 1/4, then x to the fourth times x to the fourth times x to the fourth times x to the fourth equals x. If y times y times y times y, or y to the fourth, is equal to x, then x to the fourth equals y. In general, if y to the p equals x, then x to the 1/p equals y. Notice how the base and the output are swapped. For example, we know that 5 to the third equals 125. Now let's invert the exponent and swap the base and the output. The result is 125 to the 1/3 power equals 5. Similarly, 32 to the 1/5 power equals 2. Recall that raising a number to the power of 2 is also called squaring the number. Raising a power to the 1/2 power is also called the square root. For example, the square root of 4 is 2. However, only the positive solution is the square root, so negative 2 is not a square root of 4. When the exponent is 3, we're cubing the base. And when the exponent is 1/3, we're computing the cube root. For example, the cube root of 8 is 2. More generally, raising a number to the 1/nth power is called the nth root. For example, the 5th root of 32 is 2. If the exponent is a fraction and the numerator is greater than 1, then we can use the power of a power rule to transform the expression. Here's an example. 8 to the 2/3 equals 8 to the 2 times 1/3. This is equal to 8 to the 2 to the 1/3. 8 to the 2 is 64, so this is equal to 64 to the 1/3 power, which is 4. Alternatively, 8 to the 2/3 is equal to 8 to the 1/3 times 2, which is equal to 8 to the 1/3 to the 2. And since 8 to the 1/3 is equal to 2, this is equal to 2 to the 2, which is 4.